Hello, everyone, and welcome to the Retail Strategy and Planning Series. My name is Andrew Gaffney. I'm Editorial Director with Retail Touchpoints. I'm really glad you could join us for this session. I was excited to have this session in the beginning of the series because merchandising is such a key function to, obviously, to all retailers and central to a lot of the topics we talk about with omni-channel consumers. In this session, we're going to be looking at getting the most out of machine learning and AI in a merchant-driven retail organization. Just some backstory to set this up. A lot of the retailers we speak to are very impressed, very eager to take advantage of a lot of the cool new technologies AI and others bring to the table in terms of letting machines help make better decisions. However, there's always a bit of a hesitation because merchant-led organizations have a lot of processes in place. They've been doing things their way and in a lot of ways the right way, so they don't want to risk losing that. So we've got two great speakers today that are going to give some more context and some ideas on how you can really balance both. The series is hosted and presented by Retail Touchpoints. We're hoping most of you are already taking advantage of the great content we do, but if you're not, we'd encourage you to take advantage of a complimentary subscription. That's available at retailtouchpoints.com. Also encourage you to take advantage and join some of the social conversations and channel we have going on LinkedIn and Twitter. Quick reminder to keep an eye out for our physical events as well. We do our Retail Innovation Conference. We'll be coming out with the dates for that shortly. So again, keep an eye out, and we'll be addressing topics like this in greater detail, live and in person. Throughout this week, there'll be an opportunity for registrants and attendees to win prizes. The more sessions that you interact with and take part in, you'll increase your odds of winning. There's prizes such as Starbucks gift cards, as well as free passes to the Retail Innovation Conference that I mentioned. So stay active, and hopefully you'll be one of our winners. The presentation is going to last for about 30 to 40 minutes, and then we're going to take questions. You can type questions right into the Q&A tab within the On24 platform. We'll take as many questions as we can. We'll spend about 5 or 10 minutes. If we don't get to your question, we'll direct it right to the speakers and ask them to follow up with you directly. Also within the On24 platform, you can monitor social media. We'll be monitoring as well, and ask that you try to stay active, post any comments that you like, and we'll be reposting and sharing that as well. There'll also be some related resources in the Resource Center of On24, so you can take advantage of those as well. So without ado, I mentioned we've got two great speakers. Let me go ahead and introduce those to you. I've had the good fortune of working with Kevin Stadler for a number of years, one of the real thought leaders in the retail industry. Kevin is responsible for the continued strategic expansion and overall operations of 4R. Kevin has over 25 years experience in retail technology, product strategy, sales, and software design. Prior to joining 4R, Kevin was head of customer engagement solutions for Symphony EYC, responsible for leading the product direction and business activities worldwide. So excited to have Kevin. We're also going to be joined by Vish Kanapathy, who is Managing Director and the Technology Lead for Retail globally for Accenture Consulting. In this role, Vish is focused on technology and innovation solutions serving the retail industry. Prior to his current role, he led the technology and data strategy practice and served as the CTO for retail and consumer goods industries for IBM Corp. He has over 26 years of consulting, focusing on technology and in the business domains of digital experience, merchandising, supply chain, and analytics. He is a trusted advisor and thought leader in transformational engagements, straddling business and technology in areas such as digital platforms, supply chain, merchandise transformation, blockchain, advanced analytics, and AI, to name a few. Vish has worked with clients such as Walgreens, Tiffany & Company, Home Depot, Nike, and many others. He's also an author, public speaker, and inventor. He's authored several white papers for IBM's Institute of Business Value and Retail. He's also delivered keynote addresses and actually has a patent, so really honored and pleased to have Vish join us today. So without further ado, let me turn it over to Kevin to get us started.
Thanks, Andrew. I think it goes without saying that the topic of machine learning and artificial intelligence right now is trending. It's hot. Lots of people have quite a bit of interest in it. Retailers are increasingly adopting machine learning and artificial intelligence predictive analytics, but at a much slower rate than other industries, such as healthcare, automotive, anything to do with manufacturing. And with that, it's even despite double-digit improvements in profit and reduction in risk. That said, retailers historically have been very slow adopters of new technologies, And in addition, it's also shown in our experience that the stronger the merchant-led organization is, the more fashion-forward, the more trendy the organization is, they are generally much slower on adoption of these techniques. And the question is why? Vish, are you seeing some acceleration of adoption in AI? And from your perspective, what you're seeing, what seem to be the reasons retailers are not moving any faster?
Yeah, I mean, I think we are definitely seeing acceleration. I think every client that we work with nowadays are leveraging AI, ML in some way, shape, or form. But the retailers have traditionally been slow adopters, and there is still a lot of hesitancy and inhibitions in terms of how they're leveraging AI. You know, we think a big reason for that is really more psychological. You know, merchant organization, for example, always think of merchandising more of an art than a science. And the notion that you have to pivot your business into leveraging data and using data-backed facts to run your business, surprisingly, is still foreign to a lot of people. I think people are kind of, you know, if I'm a merchant buyer in a fashion apparel organization, I kind of keep my pulse in the fashion and the trends, and I kind of generally intuitively know what sells and what doesn't sell. And that kind of intuition has served me well for many, many years. And now somebody comes along and says, I can use artificial intelligence and deep learning to uncover brand new hidden patterns that you wouldn't have otherwise thought about. That doesn't sound very, very convincing to people sometimes, I think. And I think it's really more psychological. And I think increasingly people are recognizing that, hold on for a second, a lot of these digital natives coming along who are actually applying data science very effectively, and they're succeeding in the marketplace. So I think the traditional retailers have been somewhat slow to adopt. A lot of it is primarily psychological in our view. They look at merchandising as an art rather than a science. And now increasingly they're saying, hold on for a second, I think we ought to figure out how to leverage this technology. It's still going to be slow, but I think we can see the tide turning now. It's becoming more and more mainstream.
It's an interesting concept, as you pointed out, because the promise is good. Because if you look at the strengths of, you know, relative between the two different approaches or ways to look at art versus science, as you pointed out, traditionally merchants have always been excellent at figuring out styles, trends, you know, the price-quality relationship, and the consumer psychology around what they're offering and what the products are. But at the same time, as had been mentioned, machine learning and artificial intelligence with exceptionally large data sets that keep getting larger and larger inside of retail, this kind of technology can find patterns, analyzes seasonality, does very granular forecasting, things as tricky as calculating demand transference in between multiple offers, and perhaps most importantly, having a fine sense of looking between a risk and a reward balance. So at a high level, at least, these approaches look to be very complementary, even though, you know, as Vish had pointed out, there is a bit of a psychological holdback with a lot of different people to adopting it. And we need to talk a little bit more about, you know, why is that, and what are some of the ways that we can think that through within each organization. So the trick of implementing, if you think about decisions being made that are either art, science, or both, the art decision in many ways is best made on a smaller amount of data with a less frequent sort of a decision. On the other hand, if you look at the types of techniques which have been done by machine learning and artificial intelligence and deep learning methodologies, they work exceptionally well at things that are have lots of data volume and very frequent decisions that need to be made. So the blend between the two, we term a merchant analytic or a merchant analytic model. And that way of looking at things, we believe, with the blend of the two and applying art where art is needed and science where science is good at it, you can achieve a much better blend and much better results in total. So in order to make this merchant analytics platform work, there's a lot of different framework and components to it that need to exist. To turn this type of, as had been termed, I believe Vish had talked about it previously in some conversations about a shiny, bright object, the artificial intelligence and machine learning needs to be organized. And as always with retail data, the first thing that needs to be done is integrating it and cleaning it up. I mean, even the best of retail data is still not super clean and still needs work to be put into a machine learning type of a technique. So there's normalization, there's ways to actually look at the consumer patterns and so forth. Second, many times it needs to be enriched. You might have an item, but it might not have all of the attributes attached to it that you need to go out and you need to enrich the data. And the main reason why is not because you don't have enough data, it's to get the context so that the machine can understand a little bit more of the art. Because if a consumer decision is built around certain attributes and certain ways of thinking, you'd like to have those somehow parameterized so that the machine can look at them. Next is a library of the machine learning algorithms that are specific to purpose. There's a lot of different ways that you can do deep learning, but the reality is some of them only apply to certain ways that you need to make decisions inside of retail. Then on top of that, optimization. In order to integrate into existing operational systems, you need to be able to optimize it and to be able to spit out answers that are something that can be ingested by other parts of the organization, which is that piece that we're talking about in the back end, which is the output. And if you had to kind of look at this in a layered approach, all of these different things are running in the backdrop, but on top of it, there has to be some common sense applied in terms of what is the difference between just a raw forecast? What's inventory values? What's replenishment? What are the rules and the constraints that are given to each organization? Because each organization is unique in terms of its efficiency, in terms of its model, in terms of its KPIs, what it's trying to do. And then ultimately, if you're going to be turning more and more of these large data, very frequent decisions over to a machine to do it, you need to have a system of monitoring and exception management so that you don't have to touch it every day, but when something looks a little bit off, it goes back to you. And last is the concept of having a user interface so that the merchant has a view into the analytics and can actually work with the system in their kind of a framework, which is a visual framework, a by exception framework, but at the same time gives them the types of things that they need to work with that. Vish, I was wondering if you could kind of give everybody a little bit of backdrop about the different types of artificial intelligence, machine learning, going a little bit more on the algorithms and what really is good at retail and what it's good for.
Yeah, absolutely. I mean, I think, obviously the term AI often is used very, very broadly to encompass several things. I mean, when we think about AI, the spectrum of AI, you could almost, at a very simple level, classify them into three groups, right? One is focusing around automation, and this is really largely RPA, robotic process automation, and one could argue that by itself is not AI or ML, but the reality is automation, when infused with learning techniques, can really make automation a lot more better, and we see that being used extensively in areas like finance and HR and indirect procurement, PO approvals and invoice approvals and reconciliations, or even chatbots and things like that, right? So there's a lot of it's heavily used in finance, HR, and parts of merchandising, the whole automation component of it. Then the second major area is what we call as prediction, which is all about trying to predict the future based on past observations. And this is where I think machine learning comes into play. And there's different types of machine learning, supervised and unsupervised and deep learning and reinforced learning and things like that. And I'll get into that in a minute. And really the machine learning part, I think, in my view, is largely applicable in merchandising, supply chain, and personalization for very, very clear reasons. Then the third major area is cognition, which is all about human mimicry. So this is about things like, image recognition or intent elicitation or computer vision or speech recognition or things like that. And those are, of course, have some very clear usage, especially in customer interactions and chatbots and things like that. But it's actually quite interesting to me in how these things are the interplay between them brings together a much more higher value prop. For example, image recognition and optical image recognition are now being used in merchandising in order to precede what are the attributes of a product in terms of style and color and size and height and weight, etc. Using cameras. So you can actually use cameras and put an image in a certain distance on a certain spot, and from there figure out its dimensions, as an example, and predefine those dimensions. Well, that sounds very simple and mundane, but when you have thousands and thousands of products and you're making changes to your product assortment on a daily basis, having some of those attributes preceded by a machine actually has some significant advantages. So similarly on the machine learning side, using it especially in areas like demand forecasting or product affinity and things like that. Forecasting is a great example. I mean, if you look at retail averages, retail on an average, the forecasting errors in the industry, in retail as an industry, is sitting at about 30 to 32% or 35%. In other words, 32 to 35% of all retail forecasts are actually incorrect. But machine learning, especially when you use techniques like ARI Max and things like that, it can infuse a new level of sophistication into that. And to your point earlier, which I completely agree with, which was if you look at the volume of data and the frequency in which you're having to make these decisions, machine learning really excels when they both are very, very high. And this day and age, the ability for you to do in-season forecasts and reforecast and continuously learn from it and recalibrate is becoming incredibly important. I mean, inventory is an area, merchandising and inventory is an area where you cannot underemphasize this. I mean, 52% of the working capital of a retailer is tied to inventory. So even a one-day improvement in days in inventory or 1% improvement in your forecast can make massive differences to the bottom line. So we think, so going back to your question, those three areas is where I think the spectrum of AI and ML comes in. One is all around automating typical human repeatable tasks, mostly around RPA, reinfused with machine learning. The other is around prediction, where you predict the future based on past observations with all kinds of techniques. And then the third is around cognition, which is human mimicry.
The other thing that's interesting when you think through the algorithms and this whole concept between merchant analytics and doing a way that you can visualize is trying to create a framework through which a merchant can actually see what's going on in the underpinnings of the system. One of the kind of worst situations within this is when the machine comes up with an answer, a machine learning or artificial intelligence, and there's no explanation as to why or how or what the correlation is or why it did a certain thing. So what we found is that there needs to be a way to explain, roughly what is going on under the covers so that a merchant can actually work with the system. So what you're seeing on the screen right now is, we'll build to it, and I'll show you a little bit of kind of how this framework works. In essence, if a retailer was looking at the potential of how they would handle a product within a certain demand location, so we're talking omni-channel, any demand and fulfillment location, and you look at what the actual event that occurred in terms of the forecast and what demand was, in theory, we could have played that a variety of different ways. We could have put lots of merchandise in, and if we did that, going over to the right-hand side, we would have said, you don't have a lot of profit because you would have expended way too much in inventory. On the left-hand side, we could have played it very thin and put very few items out there, but the problem is we would have lost margin because we would have lost sales. Now, the machines are exceptionally good at taking tons of data and crunching all of the different potentials out. What you're going to see here is there's actually, it's running through a Monte Carlo technique, which means it's playing through, in this instance, roughly 12 different ways that it could have handled it. It looks at the profit, it looks at what the demand was, and it looks at the supply chain and how the consumer responded, and then plots out how the curve actually would have worked for this individual item. And if you flip that curve, you get the profit curve. What's interesting about this profit curve is it shows you where you end up with the least amount of risk for the most amount of profit as it goes through. Now, does that mean necessarily you are going to take that point, which happens to be the big green point in the middle? You may not. You may actually take a riskier point and go a little bit heavier because the merchant looks at it and says, I think I'd like to actually put more in. This is trending. I think it's a good thing. The machine at this point is just guiding, but giving you a visual cue as to where it needs to be. A little bit of backdrop on this technique and the blend of kind of the Monte Carlo in this profit optimization. It's called the Markowitz model. It actually won a Nobel Prize. And where it's normally used, or most used, is in fintech for portfolio modeling and risk and how high-speed trading is done with lots of data and looking at risk-reward models and so forth. And in essence, this approach we have just applied into retail because there's a lot of similarities there with high speed, lots of transactions, risk on certain decisions you make, but at the same time reward and profit for getting things right as it goes through. Each product will have a different curve. A highly seasonal product will be very parabolic. Something that's a steady day in, day out product is going to be much more of a flat curve, which obviously inherently kind of connotates how much risk there is in each product as it goes through its life cycle. And last, probably one of the main points that should be made is using this kind of a technique, you can actually backcast through time and look at what the merchant set of decisions were versus what a machine might have done. Now, there's no right or wrong inherently with that, but what it does help is the following. Because you can run a simulation and because you can go back through time, what you can do is prove the business case for improving and actually showing a merchant where the risk is, where the reward is, and maybe wanting to play each of these just a little bit different as they're doing an initial buy or as they go through each of the seasons. The technique can roll up and roll down, all the way down to individual item at a demand and fulfillment location, up to a category, to a store, to a region, or to a total chain as you go through. But it provides you with that capability of doing that. And moreover, I think one of the reasons we've been gravitating to this with machine learning and artificial intelligence is this provides you with a much more holistic view than traditional, very silo-based types of metrics. Vish, just a question, I suppose, is, have you ever seen conflicting metrics across different silos in retail that have confuse the decision making, and examples of kind of the type of thing we're talking about of where retailers have done it right by having kind of a coordinated view of what they're trying to achieve?
No, absolutely. I mean, especially at the intersection of, merchandising and marketing, we kind of see this all the time, right? Because increasingly in this day and age, you got to have a more coordinated effort between merchandising and marketing. So what we'll often find is examples where the machine comes out and tells you, hold on for a second, these products are actually generating a lot of revenue for you, but they're not necessarily the most profitable. And when we talk to clients about it, they don't even, they don't believe it. And then we show them the data and we show them what the machine deep learning patterns are picked up, and then they're forced to admit, but these are all very counterintuitive, which I think is really the key part here, which is, machines are not emotional creatures like we are. It's not trying to, make an instinctual decision, but rather it's trying to, to your point, with things like Monte Carlo simulation, going through all kinds of, statistical probability techniques and looking at everything from, Bayesian math onwards to go figure out what are the right patterns that it can actually leverage and what's the correlation between the cause and effect. So we see lots of great examples where, products that were considered successful are not, or margins, products with high margins, but they were also featuring in baskets of very low-profit customers with products that they thought were being addictive, but they're actually not addictive. So interesting kind of statistical correlation between cause-effect behavior of customers and products can be teased out very, very beautifully with machines. And now some of them are very, very counterintuitive. So if you're simply making decisions based on gut, it's almost impossible for you to make that leap of faith unless you actually see the value in all the data. I will tell you though, there is a big challenge as part of all this that ends up happening, which is data. Retailers often don't spend a lot of time in data hygiene. And if anything, artificial intelligence, machine learning is going to shine a really harsh light on the value of good data, because with bad data, you can't really get good insights. So if anything, AI and ML is going to put a lot of pressure on retailers to almost kind of go back to basics and fix their data, because without that, you're not going to be able to take, to make use of these new technologies.
And of course, I think it goes without saying that in order to blend this world of big data, lots of things and pattern recognition going on at the same time as merchants looking at it, you need a way to view the analytics and modify the optimization if you require. It's critical to I believe it's a Ronald Reagan quote, which is trust but verify. And I think that there's a lot of truth in that, especially here, which is we need to have a trust but verify type of a perspective on that relationship with artificial intelligence, especially at retail. So you do need these dashboards. You do need to have ways that you can actually override should you see something working a little bit differently than what you might have thought. I think at a high level, just to give a conclusion point here, I think for many merchants just starting out in this type of artificial intelligence and machine learning, it's like someone's first time in a self-driving car. You still want to be able to grab the wheel until you trust it. But in the long run, the benefits of for retailers of better planning, scalability, more profit, less risk, will drive adoption of these types of technologies. In the long run, it's basically in everyone's best interest because it gives you a better result with less risk and using the best parts of machines and the best parts of humans.
All right, Kevin, Vish, thank you very much. I thought we worked in some really great examples, some really great thoughts. Reminder to the audience, we've already got some great questions coming in, but go ahead and type in questions. We'll spend 5 or 10 minutes covering those. Kevin, let me start with you. First one came in from Gloria, asked, so she said, our organization is interested in applying AI and machine learning, but unsure how to proceed in testing it. In our organization, what are recommended first steps in sort of, I guess, testing and piloting?
Yeah, absolutely. So I think the business case is always one that people struggle with when they get started, so they need that to drive things forward. And so it always makes sense to take a hard look at the current performance and benchmark it against best practices. Usually this gives you a strong business case for change. I mean, some of the things that we showed you about how you can take back data and you can actually show what the improvements would be and what those numbers are, provide you with that business case. And then to do a pilot, rather than rolling out full scale right away, to measure the improvement. That way you can then crawl, walk, then run with a clear view of what the results you're looking for as you go down the road and what you're going to get when you get there.
Vish, anything you'd add there?
No, I mean, I think just to kind of add to that. Yeah, I mean, I think just to add to that, to some extent, and this might sound a little cavalier, but to some extent, I think people have to create an environment where they're failing fast, because innovation comes with a degree of risk that I think retailers cannot afford not to take anymore, because software is killing retailing essentially at this point. So I think they need to create essentially an environment where they can very quickly experiment and fail fast and learn. There's no one answer. I mean, even if you look at things like forecasting models and things like that, depending on the categories of products, the one model works for one category and doesn't work for something else. Well, you're going to have to experiment with some of the stuff. So I think when somebody's trying to get started, I would say create a culture or create an environment where you can experiment and fail fast, and then and don't just go after the shiny objects, go after something that is more sustainable. And then I think, like you mentioned, Kevin, you have to kind of create this strong business case. That business case is not going to come overnight. You're going to have to do a little bit of experimentation, figure out what works, what doesn't. And the last point I would make is analytics is a team sport. So I cannot underemphasize the value of bringing along the larger organization and the op model surrounding it. The tools and techniques are very, very important, but by themselves, you're never going to be able to scale it. I recently had a great conversation with a very large retailer here in North America. They have a bunch of data scientists. They're doing a lot of great work, but they're all doing these little piece parts that is not really scaling in their organization because they haven't yet figured out how to convert those great work that they're doing in very specific areas, scale with the rest of the organization, and really pivot into a data-driven organization. So I think, to me, those are the big lessons learned.
Okay, great. We had another question from David. Let me start this with you, Vish, and see if Kevin has anything to add. He's asking, what are the areas of lowest hanging fruit for machine learning and AI technologies? He was potentially asking about assortment, localization, BOPIS, or seasonal.
Yeah, I mean, I think, to me, it depends on the segment of retailer you are. I mean, if you are, for example, in fashion apparel, assortments are going to be massively important. But if you're in hard goods, replenishment and being able to optimize replenishment is going to be very, very important. I think the area that we often see now, especially as retailers are trying to figure out the interplay between online and offline, creating hyper-localized assortments, in other words, assortments that are very, very localized to areas becoming more important. Part of the reason is because of locked inventory. I mean, we are working with clients right now who have millions and millions of dollars of locked inventory sitting in their store that they're not able to. It's almost economically not viable for them to go back to the store and pull it out of there. There's only so much of margin destroying markdowns they can offer. So the product should not have been in there in the first place. So they have to essentially get a lot more tighter in a hyper-localized assortment. So it's one thing to say I'm forecasting based on demand. It's a very different thing to say, am I assorting the right range in the right location based on my customer needs? I think that's an area where we are seeing an incredible amount of interest. On the execution side, supply chain, industry statistics tell you that approximately 25 to 30% of a order fulfilling cost or order processing cost goes to fulfillment, especially last mile delivery. So we are doing a lot of work around inventory placement. How do you place inventory in the right combinations of products, in the right parts of your multi-echelon supply chain in order to fulfill profitably? That means reducing split shipments. That means optimizing labor. So I think those are two probably big areas where we are seeing supply chain especially has become massively important. I mean, thanks to Amazon, supply chain went from a cost center to a competitive differentiator and a customer experience, a big part of customer experience. So we're seeing a lot of happening with things like machine learning, AI, ML in those areas.
Okay, great. Kevin, we had a question from Sandra. I thought it might be good starting with you. What are some of the key learnings when introducing merchant analytics into an organization? She mentioned she's a mid-sized retailer, but is there generally a kind of rule of thumb in terms of how and when to introduce?
Well, so from our experience of working with a number of organizations on introducing this, I'd say two things always seem to be key. The first is having a measurable objective or a key performance indicator in place, which is one that goes across organizations or silos to actually drive things. Because many times when you've got differing ways that people are measured in organizations and so forth, this kind of a holistic approach where the machine is trying to optimize everything has a hard time thriving and surviving. The second is having a plan on how to integrate with operational execution. Otherwise, it becomes an analysis paralysis cycle with lots of questions answered but no action taken, and which goes back to the shiny object. I think there's lots of people who have started up great initial efforts with data science and doing lots of different things, lots of interesting analytics done, but not as much initially attached to operational execution, and that's really where the money is made.
Okay, great. I think I'll start this one with you. Jesse asked about data, and I think you both touched on it, that having your data in order is key. He was asking for any other tips to sort of know if your data is ready for this kind of thing, and any other tips around that. Vish, let me start with you there. How critical is data, and how do you see organizations kind of get ready for that?
Yeah, I mean, listen, you can't underemphasize the need for good data, but it's also an area, I think, which tends to suffer from lack of investment, because business often doesn't see direct correlation between good quality data to good results. But, they generally understand it, but it requires some foundational things that you need to put in place, whether it is better master data governance. Even simple things like, I remember sitting in this innovation session a while ago where we're talking about some of these AI ML capabilities. One of the very reputed retailers, they kind of whispers in my ear, Vish, I would love to do all this stuff, but I don't even have proper master data on my product and product attributes all cleaned up, right? So that's just very fundamental. And it's amazing how that intersection between product and vendor and location and price and customer data is still not very, very clean. So I would say make sure you have good governance in place to get your master data in order, especially product and customer. Those two are super important, and location, I would say, coming along with that. The other thing I would say is that invest in data tools, whether it is data veracity tools, data profiling tools, data cleansing tools, because those things are amazingly powerful. And we are doing this work with a lot of retailers right now, where we are basically saying, let's help you clean your data. And it's amazing how much that's resonating in the market, because they're all recognizing that if I don't have clean data, I can't really do any of this good stuff. So I think there's no easy answer here. You can't make omelets without breaking eggs. So you're going to have to spend the time to get the data right, get the right governance in place, adopt good techniques like separating master data from transactional systems, and be able to leverage some of the newer capabilities, whether it is big data lakes and some of the data processing techniques that things like data profiling tools bring to the table, data veracity checks bring to the table, to be able to institute that good data discipline.
Great. Kevin, I know data is something you and I have talked about. Is there anything you'd add there to what Vish said, just in terms of key thoughts or takeaways?
Yeah, a couple of key points, I think, here. So when we've looked at different retailer organizations and what they have and so forth, it is all across the map. What I mean by that is some folks have good data in certain areas, not in others. And especially when it comes to applying these types of techniques we're talking about. As an example, omni-replenishment requires really good mapping of the nodes in the supply chain in order to do the types of optimizations we do. BOPUS, buy online, pick up in store, requires really good tag of where both the source of the demand was and the fulfillment was. Assortment optimization requires really good attributes as it goes through. Now, ultimately, you'd love to have all data be perfect, but it generally is not. We also produce, we've got a map model of the retail data model that's our own data item specification and data model. And the reality is we never get everything. Everybody comes all over the place. So we use what we have, identify where some of these areas are that the data needs to be improved, and then we also have some tools that we use to run correlations against the existing data to see how robust it actually is. Because there are times that good enough will give you a reasonable answer. Perfect data would give you better, but it may not be worth the data cleanup effort involved to do that.
All right, we're going to take one more question. This has been really great. Well, Kevin, I'll start this with you, and then I'd like to get Vish's perspective, too. Rebecca is saying she wants to know if this is something you feel I can do with their IT team. Do they need a data scientist? What are some of the staffing requirements in order to use AI and ML properly?
So I've seen people employ different strategies. Obviously, we have a team of data scientists. So we have seen some organizations that have no data science group come to us. We work through the initial pieces with them. The second is there are some organizations that do have data science groups, and what they're looking for is basically a cloud-based environment and a model that they can actually produce and use those kind of tools inside of it, which is a lot of the kind of modeling we do and so forth. So I would answer that question by saying I don't think there is one perfect way to look at it. You can test and work with organizations like ours that have data science teams and so forth, or you can actually go out in the marketplace, hire, bring people in and so forth. The best obviously is you need to have people with retail experience, because data science without some understanding of how retail works tends to be a bit of a fishing expedition.
Vish, is it something you're seeing retail companies turn to companies like yours to help with? Or?
Yeah, absolutely. I mean, I think I mentioned earlier about data being a team sport. I mean, we think about 12 to 14 different roles that make up kind of good, better analytics type organizations, and surprisingly, data scientist is only one of them. I mean, you need everybody from business Bs and visualization experts. I mean, I can't tell you the number of times we go to clients who will say, yeah, we invested in a data lake and we got a bunch of data scientists, and you throw the data scientists into the lake and ask them to go find something, and that doesn't sound very sustainable to us. I think, just to, just kind of go back to Kevin's point, I mean, yes, you need data scientists, but that's not the only thing. You've got to have a much more broader and well thought out strategy in what are you going to do with the data, what kind of interesting questions you want to ask of the data, where are you going to apply it, how is it going to be embedded into the organization, how are you going to pivot into a better decisioning organization. And yes, in order to execute on all that, you need several roles, data scientists being one of them, but you need everything from, for example, increasingly, and especially given some of the amazing, spectacular failures that you see in the marketplace of AI being leveraged incorrectly, and there are great public use cases, I won't get into every one of them, where it clearly shows that, listen, AI can do a lot of great things, but if you give it bad data, it's going to give you really bad things very, very fast. So being able to kind of understand how you're going to use it and how your machines are going to explain itself in terms of what answers it produce are going to be increasingly important. We often hear this term explainable AI coming up into the fruition nowadays, because it's one thing for a machine to come up with an answer, but you have to be able to explain how you got to that answer so that we can reverse engineer if that really made sense. So I think there are several roles, data scientists being one of them. You really have to think of analytics as a team sport and think of it as something that you want to embed into the culture of the organization first.
All right. I want to thank you both. These are really outstanding insights, and I think some really actionable takeaways for our audience. So thank you for all the smarts and bringing those to us today. I want to thank our audience for joining. Some quick reminders. The session obviously will continue this week. You can go ahead and check out the agenda and pick out sessions that are most applicable to you. They're available live and on demand. Our next session is going to be at 3 p.m. It's on the 2019 Premium Loyalty Data Study. It's going to look at will customers pay for loyalty programs. So hopefully you can make that. Again, I want to thank Kevin and Vish for a great presentation, and hope you all have a great rest of your day.
Thank you.